Welcome to our presentation, Two All-New Solutions for Contact Lens and IOL Manufacturing from the pioneer in freeform surfacing. My name is Stephan Huttenhuis, and together with my colleague Frank Niehaus, we would like to show you who we are and why do we do things differently. The following presentation will give you insights about who's Schneider. Why do we have 25 years of experience with ophthalmic machine building? What makes Schneider different? What is freeform and what is it good for? As well as what does influence lens quality. We will have a look on how automated IOL and contact lens manufacture could look like in near future. And take a look on Schneider's two brand new machines for IOL and contact lens manufacture, the UPC 100 and the UPC Nano. This is the UPC Nano. It is a very compact machine with an extremely low investment price. It features an onboard fast tool system that allows for non-spheric machining, like toric or freeform, for a price less than most spherical machines. Plus, the machine is ready for automation. A more deep investigation of this machine is part of the following presentation. This is the UPC 100 Vision. Its core design is based on Schneider's highly accurate, ultra-precision single-point diamond turning machines. Based on hydrostatic guiding and extremely low-noise drive systems, the UPC 100 Vision creates excellent surface finishes for polish-free applications. You will get a more deep introduction of this machine in the following too. So let's get started. We are a quite young company, founded in 1986 and became the pioneer and worldwide supplier of freeform technology. We have around 480 employees globally, and 10% of those are apprentices. We are building around 500 machines per year. We are a global company. Our customers are distributed throughout the whole world. Our export ratio is far more than 90%. As a consequence, our service points are very international too, allowing to provide local service in mother tongue in many cases. Our products can be found in the ophthalmics, which is our biggest division, precision optics, where the company started with, and in ultra-precision optics. Ultra-precision machines are considered to be the most accurate chip-removing machines possible. Higher accuracies cannot be gained mechanically anymore, but would require techniques like electron beam or lithography. Our machines are used for a vast variety of applications, like camera lenses and space telescopes, sun and prescription lenses for spectacles, or head-mounted devices in augmented and virtual reality applications. Our company slogan is called Fascination for Innovation. This means we are always keen on creating solutions that can do more. It became a passion to push limits which were considered to be unchangeable. This dedication allowed us to rewrite the story of lens manufacture and spectacle lenses. And we believe this can be done for contact lens and IOL too. So why freeform? Each eye is very unique. Freeform gives you the highest flexibility in lens design and correction. Freeform machinery can do spheric, aspheric and toric lenses, but are not limited to those geometries. Freeform allows to exactly replicate the shape of the cornea, for instance as a starting point for designing best varying comfort and tear film propagation, or to correct additional high-order aberrations like astigmatism, coma, trefoil, etc. But the more demanding the lens, the higher the demands on the machine and machine dynamics. So which factors do influence the quality of a lens? A first set of influencing factors is defined by the quality and performance of the design itself. How well does the lens design meet the physiological needs? How uneven is the geometry of the cornea? To which extent can I or need I respect high-order aberration? A second set applies to the mathematical description of the design file. What is my geometrical basis upon which the design is transferred to the machine? Do I have a point cloud or a mathematical expression like splines or NURBS? Even a well-thought design can be difficult to machine if expressed not adequately. A third route applies to the transition from design information to the according machine axis movement. What is the related acceleration and slope of the axis? How can I avoid a decrease of data quality within the multiple conversions from designer to controller, to NC code generator, to the drive, and finally to the axis itself. And a fourth group is the process design itself. What parameters should be used, and what is the best compromise between throughput and quality? So there are a lot of influencing parameters that need to be taken into consideration to make sure you get the best possible lens quality. Schneider is paying attention to all of these aspects since more than 25 years. We developed our own software and mathematical architecture to extract all relevant data from the design file to create an automated NC code engine. And we designed according regulation loops, and even the dynamic motors are designed and produced by Schneider itself. We take care that our regulation loops are fast enough and our motors quick enough that even the most complex freeform designs are met with highest precision. We take care that our drive systems have lowest noise levels to avoid unnecessary surface roughness on the lens. All this is done with one goal in mind: to create the best possible lens quality. So since the beginning of freeform, Schneider deals with mastering all quality influencing factors and made freeform machining the core competence of the company. Our journey as a pioneer of freeform machining started in 1994. Today we have an installed base of more than 1,500 lathes running 24/7 in most cases. Over time, we were able to offer dedicated solutions to all different aspects of the spectacle manufacturing chain. Our path led us from single standalone production machines to machine lines to a fully automated self-balancing production system with integrated lens logistics. Today, we are a full solution provider in the ophthalmic business, including software. What you can see in this video is the first industry-proven, fully automated spectacle lens production system. We call it modular. Modular allows to integrate many different types of machinery into one lens logistics system. Its basic philosophy is to organize the workflow completely by itself. The system understands which lens can be machined at which place and takes care that all machines are running as much as possible. This allows for the best throughput and the best utilization of your investment. Highly efficient production needs good monitoring abilities. The modular control center tells you for each machine the according production status. Does it run or not run? How much lenses were made? It shows the overall equipment efficiency and guides you in case of a breakage. The following video shows you the whole production system is monitored and controlled by the modular control center. The virtual lab overview represents the layout of your lab and shows you critical information at a glance. Modular allows for middle and high volume production, but still gives you all the flexibility that is needed to keep each lens unique and different. This system is used in spectacle lens manufacture since 2013. In the meantime, over 100 million lenses were already made using the system. We believe that fundamental principles can be converted to contact lens and IOL manufacture too. It may not look the same, but it will be able to do the same. Our journey from 1994 until today considerably changed the way of automated lens manufacture and forced us to continuously reinvent ourselves by driving innovation. It paved our way towards becoming a full solution provider. And now, we want to convert this experience into contact lens and IOL manufacture. Our first step is the introduction of these two brand new machines, UPC Nano and UPC 100 Vision, that will be presented in more depth by my colleague.
Thank you, Stephan. My name is Frank Niehaus, and I will talk about the details of our two new products for the contact lens and IOL industry. I would like to start with a smaller UPC Nano shown on the left side. The UPC Nano is a very compact machine for the contact lens and IOL market, and the focus is on a very good price-to-performance ratio. Already in the basic configuration, the machine comes with an onboard fast tool that is able to carry up to 3 tools. This allows to machine a wide range of optics, spherics, torics, sclerals, and even freeform lenses. Usability has always an important role. Hence, the innovative axis arrangement supports the operator for an easy and quick tool calibration without manual adjustments using only an Z-axis. The graphical user interface in combination with a touchscreen is also very convenient to use. With the machine you can get an optional laser marking unit, and the machine is also ready for automation. For safety, the whole machine is fully enclosed, fulfilling highest safety standards in the market. All these features are integrated in this compact machine, having a footprint of only about 1 square meter. This slide gives an insight into the machine chamber and describes the axis layout. The main linear axes are the x-axis, carrying the spindle on the left, and the fast rule holding up to 3 tools on the right. This enables etching, roughing, and finishing of convex as well as concave geometries. The distance between the cutting tools allow for a maximum workpiece diameter of 25 mm. With this special tool setup, we really turn the whole process upside down. The nozzles, which can be activated individually by the controller, blow from the top, and the chips and swarf is leaving the working chamber through the base of the machine by an exhaust system. The chamber is not only prepared for spray misting, but also flood cooling is possible, which can have a positive effect for certain processes. The air-bearing spindle comes with an automatic collet for a diameter of 12.7 mm and has a maximum speed of 10,000 RPM. All in all, the compact machine base in combination with an air spring isolation unit allows for sub-micron accuracies in the lens manufacturing. Let's see how the machine is operating. Here we see a video about the machine process. It's about the cutting of the backside of a lens. It starts with the machining of the outside diameter. After that, the lens is further processed by the roughing tool in the middle. As mentioned earlier, the geometry is not only limited to spherics, but already with the base configuration of the machine, torics and even freeform scleral lenses can be machined very efficient. Finally, the finishing steps take place with the third tool. The detailed view onto the scleral lens cutting shows very nicely the dynamic motion of the tool in the millimeter range. The motion control and the toolpath calculation base on algorithms that we developed for the freeform machining of spectacle lenses, ensuring high form accuracies, as Stephan described earlier. Okay, lens finished. Let's have a look how the machine is operated. The machine controller bases on an industry PC with high availability and robustness. We use the same controller type in our ophthalmic machineries that are running all around the world and very often 24/7. The operating system on the PC is Windows 10 in the 64-bit version. Also, the CNC is running in 64-bit mode, allowing for 10 nanometers programming resolution. The modern Windows enables also the easy connection to your local area network. The interface for the operator is a modern touch display. The picture shows the main screen that allows for loading lens data files and the calculation of the toolpath. Then the cutting process can be started by hardware buttons. Different data formats can be loaded to and processed by the HMI on the machine. We can work with meridians or point clouds. There's also an interface for the focal point software package. Since we do all the software developments in-house, we are also open to integrate other formats and interfaces. Just let us know what you need. Earlier I was already referring to the tool calibration routine. What is meant by that? Due to the innovative axis arrangement, we are able to correct the tool height by refining the fast tool position. By that, the operator just has to type in the determined tool offset in height, and with the position of the NC axis, the machine does the adjustment by itself. Besides the ease of use, this allows for a very rigid connection between the cutting tools and the dynamic moving fast tool slide. excluding any tiny adjustment flexures or mechanisms. And in the end, this increases surface finish of the cut lens. Of course, you'll find all required tool information in the tool database as part of the HMI. There you can also correct the tool position in the other directions like X and Z. Optionally, you can get with the machine a fully integrated laser unit, directly placed next to the cutting tools in the working chamber. This allows for safety class 1 operation without any further measures for protection. You can use this for different engraving tasks like ID codes, alignment marks or logos. The constant engraving quality is ensured by laser beam stabilization, overcoming well-known issues with CO2 laser units. But the real specialty of this laser is that it's using a scanning mirror, as you can see in the sketch beside the picture. By the moving mirror, the laser focus is moving over the lens surface. This avoids time-consuming repositioning of the lens with the machine axis for every dot in the marking. Hence, even larger ID codes or special engravings are done within seconds. The UPC Nano is prepared for automation and can cooperate with different principles. Therefore, a handling system is integrated into the machine for moving the lenses in and out, handing them over to the spindle. Outside the machine, there are different various possibilities. A robot can be used to hand over the lenses to other machines for following processor steps, or to combine the machine with an existing storage. Of course, the handling system can also cooperate with multiple drop pallets, as can be seen in this illustration. If you want to set up a large system comparable with our modular system that we introduced in the ophthalmic market, or if you prefer a kind of one-piece flow, you can combine the machine by the handling system with a conveyor belt moving single drop pallets through the production. By that, different solutions are possible to be most flexible for your needs. Of course, adapted solutions can be discussed if you have specific needs regarding capacity or specific block piece geometries. Just talk to us. All in all, it is an investment in the future, enabling an increase in productivity of your lens manufacturing. So far, the introduction of the UPC Nano. Let's have now a closer look at the UPC 100 Vision. As you can see in the graphic below the pictures, the UPC 100 Vision is designed for a wider range of applications. Besides lenses, it can also be used to machine molds for the mass production of lenses. This is possible since the UPC 100 Vision has been developed to achieve excellent polish-free surface finish combined with very high form accuracies. For this reason, we choose most modern control and drive technologies, hydrostatic guidings for perfect damping and stiffness, and a granite machine base for the thermal stability. Hence, the design follows principles of ultra-precision diamond turning technologies. Although its high capabilities, the footprint of the machine is still small. The electrical cabinet, the hydrostatic pump, as well as the chiller are all integrated within the housing. As the lower picture shows, the machine offers high flexibility. Due to a lot of space on the machine slides, you can arrange the tooling setups for your specific needs. The controller and the user-friendly graphical user interface come with unique data handling capabilities, in combination with the touchscreen panel. The machine has further a full enclosure to meet strict safety standards in the market. Nevertheless, the housing as well as the controller are flexible for later integration of an automation system. Similar to the solutions that I introduced for the UPC Nano earlier. Let's have a closer look at the working chamber. This picture shows the axis layout of the machine, which comes in the basic setup in a 3-axis configuration. The fast tool for torics and freeforms is optional and will be mounted next to the tool holder on the X slide. The travel range of the X-axis is 250 mm and a T-slot plate allow for flexible tool arrangements. The Z-axis offers 150 mm travel and carries the air-bearing spindle, with an automatic clamping collet for the arbors as a must for automation. In addition, each tool holder has its own programmable nozzle for air or spray misting during the cutting process. An exhaust system is available as well. Especially for IOL manufacturing, the machine can be adapted with a cryo-freezing unit. Here, the enclosure enables noise reduction and reduces contamination of the lab by chips and swarf. Okay, let's have a look how the machine is running. Here you see both machines in our development lab in the factory. Through the sliding door, the operator has access to the working chamber. Again, the cutting process starts with a reduction of the lens diameter after blocking. Here we see the cutting of a contact lens design, followed by the cutting of an IOL geometry. Due to the high surface quality and stiffness of the machine, you can also machine molds for the replication of lenses. Aluminum or nickel coatings are typical materials for such molds. The next slide will explain one important piece for achieving this high surface finishes. The drive technology has a significant influence. We choose for the UPC 100 vision digital drives with clock rates in the range of 100 kHz, linear motors and high-resolution scales. In combination with the mechanics of the slides and the hydrostatic guidings, we achieve smallest volume errors. The graph shows the noise of the x-axis, which is below 1 nanometer PV. By that, nickel coatings for molds can be machined with roughnesses below 1 nanometer RA, as shown in the white light interferometer measurement. But also the form accuracy is important, especially for molds, since you copy the shape during the replication process into thousands of lenses. This slide shows the interferometer measurements of a sphere cut in aluminum and achieving form accuracies way below 100 nanometer PV. Let's have a look at the controller of the machine. The machine controller bases on an industry PC with high availability and robustness, very similar to the earlier introduced UPC Nano. The Windows version 10 as well as the CNC is running with 64-bit for high calculation accuracy. This allows us highest programming resolutions of 10 nanometers for very precise setpoint data. The modern Windows enables also an easy connection to the local area networks. The interface for the operator is a modern touch display combined with hardware buttons for the main functions of the machine and a keyboard. The HMI software developed in-house is able to process different data formats. Besides meridians, point clouds, and of course the focal point software, interfaces for NURBS, Zernike, or other polynomials are ready. Similar to the UPC Nano, we can also use up to 3 tools with the fast tool, for changing between roughness and finishing, or for keeping more tools ready for overnight manufacturing. Again, the tools are mounted rigid to the fast tool slide, and height adjustment is done via the tool database and a programmable fine adjustment of the fast tool axis position. This is very convenient, quick and precise, and avoids any weak and not stable flexures or other tiny mechanisms. Last but not least, I would like to come back to the outside shell of the machine and the integrated safety aspects. The full enclosure protects the operator, reduces noise and contamination of the surroundings in the lab, but it is also required to fulfill the regulations regarding safety for machine tools. This is not only achieved by the housing, but by a number of different measures like safety glass, door interlocks, functional safe emergency stop buttons, process camera, and so on. Hence, many things that ensure a safe operation of the machine and of course protecting you and your staff in the laboratory. This is already the final slide of our presentation. about who we are and what solutions we can offer for the contact lens and IOL industry. Thank you very much for your attention, and check out our website or social media activities to get in touch.